Let's talk about population parameters. Population parameters are things that we use to describe our population. In particular, we use the mean and we use a margin of error that we get from our sample size. The mean of the data in a sample is used to give information about the overall mean in the population from which that sample was drawn. For example, if we want to talk about American teenagers, it's very rare we could ever gather up every single American teenager and ask them how they feel about something, but we can use a sample size in order to make predictions about the population. When our margin of error is larger, when our sample size is larger, that makes our margin of error smaller. So let me repeat that. When the sample size is large, so the more teenagers I could interview, the less of a margin of error I would have. In other words, the more confident I would be about my statistics. So let's talk a little bit about some of these examples. Margin of error you calculate by doing 1 over the square root of n being your sample size. And again, what I just said is written right here. The larger the sample size, the smaller the margin of error, which is a good thing because you want your margin of error to be small so that you're confident about your data. So I just put 2 little examples down here to show you. If I calculate 1 over the square root of 40, so my sample size was 40, I would get a margin of error of approximately 16%. But if my sample size were larger, say 400, I only have a margin of error of 5%, so I'm much more confident when I make this estimation about my data. Let's look at a few more examples. So these 2 are talking about if we have a survey and we have a percentage of people that prefer something, but we want to figure out our margin of error. Margin of error is kind of like how confident are we about this data? So let's look at example 1. A survey of 300 moms found that 13% of moms prefer cloth diapers. Now I just made that up, so that's not true, but we can pretend like it is. So to calculate my margin of error, I would calculate 1 over the square root of 300. Because 1 over the square root of n being my sample size, is my formula. That gives me, and I've already calculated it, 0.058, which is about 5.8%. So let's say we'll round up to 6%. So what we say is we have a confidence interval, 95% is our confidence interval, that 13 plus or minus 6 is really truly where moms really actually fall. So really 7% to 19% of moms prefer cloth diapers. 13 is there in the middle. It's our mean of our sample size. So 7% to 19% we call our confidence interval or our true interval of where moms really fell. About 7% up to about 19% of them actually answered the question that way. Now what about a survey of 25,000 American teens that found that 65% of American teens prefer Apple to Samsung? Again, I made that up, but let's just pretend like it's true. So let's say 1 over the square root of 25,000. Notice that sample size is really large, so our margin of error should be really small, which it will be. So I've already calculated that's 0.006. So our margin of error is only 0.6, which is really good. So we could be confident about that if this was a true survey. And so then I would say 65%, this is if they wanted my interval. Sometimes they might just want the margin of error, and sometimes they might want the whole interval. So 65% plus or minus the margin of error gives me my confidence interval. So that would be 64.4 to 65.6% is where my true interval falls. 95% of my people actually answered somewhere in between there. So let's look at 2 more examples about what they might ask you about. So for these 2 examples, we're trying to figure out what would need to be the sample size if we want to keep our margin of error at a certain percentage. And so to do a survey and have a margin of error of 5%, what would my sample size need to be? That could be a question you're asked. So let's say 0.05. You want to turn the percent back into a decimal and then set it equal to your little formula, 1 over the square root of n, and then we're solving for n to figure out the sample size. So first I would multiply both sides by the square root of n. So I would have 0.05 square root of n equals, and then these two cancel out, so that just equals 1. Then I could divide both sides by 0.05, and I'm going to carry on over here. So we have the square root of n is equal to 20. But then I don't want the square root of n, I want n. So I'm going to square both sides at that point, and n will equal 400. So I can tell that I need a sample size of 400 in order to get a margin of error of 5%. And that's also the example I used on that very first board. So sometimes you can even memorize them if they ask you about them frequently, but if not, you can always calculate it with your formula. And let's do one more example. To have a margin of error of 15%, what would my sample size need to be then? So let's do 1 over the square root of n is equal to 15%. Again, we put it back into a decimal. So that would be 0.15 square root of n equals 1, because we can multiply by the square root of n, and those would cancel out. Then we could divide by 0.15, so we get the square root of n is equal to, and this one was a decimal, 6.6 repeating. And then when I square both sides, I end up with n is equal to 44.4 repeating. So let's just say n would equal 44. And if you ever have a question about how to round it, you can plug your sample size back into the little 1 over the square root of n formula and just make sure it would give you 15% again, and this one would. If I plug in 44, it still gives me 15%.